Hello everyone, welcome back to today's class and we will learning chapter number 12 electricity. So till now we have learned about the Ohm's law, and in the Ohm's law we got the formula V equal to IR, and where V is the voltage, I is the current through any conductor, and R is the resistance of the conductor. So R, the resistance, is a new term for you, and resistance is the ability of any conductor or the property of any conductor to oppose the flow of electrons. And now we'll see how the R changes, or on which factors the resistance of a conductor depends. Factors on which resistance depends, means resistance of a conductor depends. So first of all, resistance depends on the type of material, what kind of material we are using. So as we are talking about conductors, so obviously we'll be talking about, or we'll be using metals. So first we'll see how the length and the size of the metal depends or affects the resistance. Number one, resistance depends on length. Length of conductor. Means if the conductor will be more longer, then the resistance will be more. R directly proportional to the length of the conductor. The more longer conductor, the more will be resistance. Second one, number 2 is resistance is inversely proportional to the area of the conductor, or we can say like the area of cross section of the conductor. So R is inversely proportional to area. That means if the thickness of the conductor increases, then the resistance will decrease. If the thickness of the conductor is less, then the resistance will increase. So using 1 and 2, these are the 1 and 2. So just let us understand how this works. So first of all, the length. The more longer will be the conductor, the more resistance there will be. That means if the electrons of the atoms of the conductor will try to resist the flow of current move. And if the current object or the conductor is very thick, then it will be easy for the electrons or for the current to flow through it, as there will be more area to inside the conductor. So here, when we are talking about the cross sectional area, then we are talking about this part, the circular part. It means if you take any conductor, basically a wire. So if you look to a wire, it looks like a thin thread or a string. So if this is a string, if you cut one piece, if you just cut it from here and try to look it from the cut part, means from the cutted part closely. You will see that that part is basically circular in shape, and we take the area of this circle, which is here. So normally if we are talking about any wire, so that wire is actually cylindrical in shape, and we take the area of that circular part, which is known as a cross-sectional area. So you can note it down. So from these two, noting this part. So we got R proportional to L, and we got R proportional to 1 by A. So using these two, from this 1 and 2, we can write R is proportional to, or write it here, R is proportional to L by A. Length is directly proportional to the length, and resistance is directly proportional to the length and inversely proportional to the area. We get this R proportional to L by A. Now, as I told you earlier also, when there is this proportional symbol, we cannot find a proper conclusion, we cannot reach to a proper conclusion. So we need to remove this proportional symbol, and here this symbol is replaced by R equal to rho. This is written like this. Just see here carefully. Here, here, here. L by A. This term is known as rho, and this is the electrical resistivity, or we can say like directly we can say like resistivity. Resistivity of the conductor. Rho is the resistivity or electrical resistivity of the conductor. Now this rho has a fixed value for a fixed metal. That means if you look to your book, page number 207, table 12.2, on the top of the table we have conductors: silver, copper, aluminium, tungsten, nickel, iron, chromium, mercury, and so on. And if you see there, the resistivity values of different metals are given. For silver it is 1.60 into 10 to the power minus 8 ohm meter. For copper it is 1.62, and for aluminium it is 2.63, and like this it goes on increasing. So this resistivity value provides us of the information that how much better it will conduct the current. So if the resistivity value is less, then the metal's conducting property, electricity or current conducting property is very good. It can conduct current in a far better way. So, and if this resistivity is high, this value, rho value is high, then that means the resistance of that object or conductor is not so good. So here we have silver than copper. Now silver has less resistivity than copper, little bit less. So silver conducts electricity in a far better way than copper. But since silver is a costly metal, so we cannot use silver for making wires and equipments from it, because they will be far more costly. Second, copper. Copper has far more better resistivity or lower resistivity than aluminium. That means copper conducts current or electricity in a far better way than aluminium. That is why most of the wires in our homes, the wires used in the fans and electrical components are made of copper, which gives a very good amount of electrical conductivity. So this formula you have to remember. Rho is R equal to rho L by A. Rho is the electrical resistivity of the conductor at a certain temperature. Basically, this resistivity, that means this rho value is taken out or is find out almost at 20 to 22 degrees Celsius. Because sometimes for some metals what happens, if the temperature increases then the resistivity also changes. Sometimes it can go up, sometimes it can go down. So this much only for today. Next we'll continue with the series and parallel resistance. Thank you.